Okay, let's see how that is. That's the best we can do. Hopefully, hopefully they come back. You know? That's all we can ask, you know? All we can ask, you know? Okay. And I'm just going to get the chat again. Okay. Okay. All right. I think we're in, right? Okay. All right. Hopefully Samuel's back. We'll see. Just wanna pop this off my. All right, cool. I think we're set. This just needs to be a little bit, I believe. That's not bad. Okay. Okay, cool. So there we are. Okay. I think I didn't do it this way, right? Why not? Okay. Cool. So let's answer one of these before Samuel gets back. Okay. Okay. Cool. All right. Hey, Samuel, you found me. I was I was wondering whether you would. All right. How's that delay? It had been about 6 hours, and this computer's not necessarily a fresh one, let's just say, so wasn't a big surprise. Yeah, let's do it. So, okay, so this is from A to B. You said it was 3. All right. So then what is it from B to A? So and what we're doing here is we're sort of pausing the journey. We're sort of on our way this way, then we're on our way this way, then we're on our way this way, on our way this way. And what we're doing is we're stopping at P. So, and at that moment, I was going in this direction, right? At that moment, I was going in that direction there, right? And so if we go the other direction and we stop right here, you'll notice that this is always a 90-degree to the direction that you're going, right? The angle of the rope, or the angle of the center, right? And so what is the direction that we're going as we get to B? Which one represents it? It wouldn't be this, because that's a bounce back, right? It's not bouncing back, it's just continuing on the journey. So which vector represents continuing on the journey? 3 is going A to B. Yes, you're absolutely right, Samuel. So that's right. That there is A to B is vector 3. Okay. What about from B to A? What about from B to A? Yeah, exactly. Right? If you're the green thing, if you're on your way back, right? It's not going to bounce up. It's not going to bounce down. It's not going to bounce directly back. It's not going to bounce up and back. It's going to just keep going in that direction, right? So vector 4 is B to A. Yeah, well done. Beautiful. Okay. What else you got, world? Give me more, Samuel. Come on. I like hearing that you and your friends. Nice. Like to hear it. Well done. Let's go. So, what else we got? I can try some of these problems, or you can give me your next problem that you guys are working on. Talk to me. We can do this. We can do this. What do you got? All right. Beautiful. Okay. Okay, let's actually try the second one here. Try this. Suppose you find 7 articles related to the topic of your research paper. In how many ways can you choose 5 articles to read? Okay. So this is important for sort of knowing, you know, picking 5 out of 7. How many ways can you do that? This is for sure. Yeah, Samuel, hit me. Put it in the Discord. Put it in the chat. Whatever you have. I want more. Alright? I want more questions. Give it to me. Okay. All right. You don't have to necessarily translate. I can, if you want to, you can throw them in the chat. But it is helpful. Yeah. Okay. Awesome. You send the original. Okay. So let's put this one on the back burner. Okay. Yeah. So send the original and then help me with the translation, and I'll see if it's the same as what I kind of suspect. Okay. That's perfect. Okay, so I'm just gonna do this. Boom. We're living in the future. All right, your textbook's now on the screen. Okay, so an object is moving in circular uniform motion and it passes the points A, and 1 second later it passes point B. Oh, look at this. I speak Portuguese. I don't speak it. I read it. How was that? How close was I? Or am I just looking like a fool now? Okay. A acceleration is the acceleration over this interval. Okay. I'm good. Okay, thanks. So, okay. So it moves in circular motion and perfectly uniform because, you know, from the last question, those speeds are the same, right? And that's important. So the speeds are the same. So that's uniform circular motion. And then it says it takes 1 second to pass. Okay, well, how much of the circle is that? How much of the circle is from A to B? Right? How much of one full revolution? Is it one full revolution? Is it 2 full revolutions? Is it half of a full revolution? Is it a quarter of a full revolution? Is it an eighth of a full revolution? It's 1/4 of a full revolution, right? It's 90 degrees. It's 90 degrees of the full 360 degrees, right? Okay, yeah. Yeah. Perfect, thank you. Yeah, okay, so awesome. That's what I had kind of like had it in my head too. Okay, so back to this here. So it asks about from A to B, right? It's going from A to B, but that's not 1 full revolution, right? It's a quarter of a revolution, and we can get that looking at the degrees, the 90 over 360, right? Okay. So it's a quarter of a full revolution. And how long did it take? It took 1 second. Right? So if it takes this, let's do this, let's do that. Okay. So if it takes 1 second to do a quarter, then it will take 2 seconds to do 2 quarters. And then 3 seconds to do 3 quarters. And then 1 full revolution will happen in 4 seconds. Yeah? Okay. Thank you for your input. Abacheo. Vom red. As I've always said. You know? Okay. So it takes 4 seconds for 1 full revolution. Okay. But what they're asking for is the... And we could, you know, use this number to answer the question, but it's easier for us to use this number. Okay. But what they're asking for is the acceleration, right? And the acceleration, well, this is uniform circular motion, so the acceleration is the circular motion acceleration formula. It's the tangential velocity squared divided by the radius. Right? But we don't really know the radius. That's a problem. We don't know the radius of this thing. So there's no way we're going to use this formula. There's actually another way, right? Because I mean, we know that it takes 4 seconds to do a full revolution. And we know what speed it's going around that circle, right? So that means that it's traveling at root 2 meters per second, you know, which is an ugly number, but it's just a number, right? So it's traveling at root 2 meters per second for 4 seconds. So what is the delta D? Right? Well, this is a delta D type formula, right? So this is a V times delta T, which is root 2 times 4. This pen doesn't like when I write my 4s. Okay, so 4 root 2. Right? 4 root 2 is that number. It's a simpler number than actually solving for it. But that's in meters. Right? Okay. This is a little too kind of... I don't know. I'm looking for a little bit more...
I've got my essay written. And
You've got it
I've worked on
written?
for about
Oh
a
my
week.
gosh.
So now I'm going to show you how I use Grammarly to edit.
Okay, thanks. Okay. Yeah, exactly. Right? We need to find the radius. So the delta D, well, the delta D is sort of like if you lay out this circle, that is the delta D, right? If you sort of open this circle up and bring this side down and bring it down like this, you're going to open it up, right? And open it up this way and lay it flat. You're going to get delta D, right? Well, that means that's the circumference. That's the circumference. So that is actually the key to the question there. That right there is that it's the circumference. Yeah? And knowing to go there. Okay? Because the circumference is 2 pi r. And we're saying that this is the circumference. So that's equal to 2 pi r. Right? Oh, my big old head's in the way. My big old head. Don't you worry a thing about my big old head. I'll be moving that. There we go. Make things a little bit smaller here in Texas. Alright. So... boom. Okay, so we can say for root 2, which was the distance, you know, that this thing traveled in 4 seconds, it's 2 pi r. And so r is 4 root 2 over 2 pi. So it's, what? 2 root 2 over pi? Is that right? And so now we would solve. Or we can even just bring that in, right? 2 root 2 over pi in meters, and just bring that in because we don't ever really ask, we're never really asked for the radius. So we know that we need that. You said it yourself, and now we can plug it in there. So we have the root 2 squared over 2 root 2 over pi. And now it actually might be easier to solve it, okay? So let's actually just solve it instead of doing that because it doesn't actually save us. So let's just do this. So 2 times root 2 divided by the old friend pi is about 0.90 meters. And so 0.90 there. And we get 2 over 0.9, so it should be a little bit bigger than 2. Should be a little bit bigger than 2, right? Uh-oh. I mean, maybe it's asking which one is it closest to. In that case, I would still say B, right? But yeah, let's just double check. 2 pi r, that is our circumference, yeah. 2 root 2 over pi, yep. 0.9, yep. Yeah. Right. So this is like 2.1-ish. .22-ish. And that's meters per second squared. Okay. Boom. I just want to double check that I did do that right. So root of 2 times 2 divided by pi. Yeah. Yep. Okay, and what about this? Delta D is yes. Yes. Yeah. Yeah. I think I'm okay with this. How do y'all feel about it, Samuel? How's the digestion coming? You understanding? You finding it difficult? Talk to me. Does this make sense? Was it too quick? Are you translating? Talk to me. My friend said that he saw a video about this question. Bonus number 2. Okay. Cool. Boom. There you go. I wonder if or if we can kind of get rid of the radius too. Cheat a bit. No, I don't think so. Yeah. Yeah, I agree. Okay, hit me with the next question. Put it in the chat. You're on number 4. I'm assuming number 5 is coming. I'm gonna go back to the sheet. Back to the sheet you sent me. Number 5's got to be coming, right? 5's got to be coming. All right. Let me translate it for you. Okay. A figure represents un carro de Formula 1. Okay, a Formula 1 car. Creando numa curva da pista de corrida. That's all you're gonna get out of me. How horrible was that? I read it like it was Italian. Okay, Samuel. Love it. Okay, let's just do this. Let's do this. Let's cheat a bit here. Boom. Boom. And boom. Okay. You sent it. All right. A figure represents Formula 1 car braking on a curve in a racetrack. Okay, cool. Sure. Okay. Which force results is... I don't know what this is. Okay. So which vector... What does the vector represent? Which resultant force acting on the car at that instant. Okay. Okay, this is interesting. So they are braking on the curve, or are they taking the curve? Like, are they staying at the same velocity? That's really the question, the important question, right? What do you assume? Do you assume that they are staying at a constant velocity around the curve, that they're slowing down around the curve, or that they're just taking the curve and, like, it does say braking, you know, on a curve. Stopping. Okay. So then, let's ask the question, right? Remember that last time that we had that sort of circular, you know, spot where we are going to ask about sort of two types of acceleration, right? So that is our tangential acceleration, and that is our circular acceleration, right? So this is the AT. Right? So remember, for uniform circular motion, we need VT to be constant. We need it to be the same thing the whole time. We need it not to change, right? Okay. Okay, thank you, Samuel, for the clarifications. That's great. So VT needs to be constant for there to be uniform circular motion. And in that world, when that is the case, then AC is the only acceleration. Okay? And AT is equal to 0. And we could point to this to say the velocity in the tangent is not changing. It's constant, it's not changing. And so the acceleration is 0. That's what acceleration tells us, right? Whether that velocity is changing or not, okay? The reason that this is allowed to continue is because this is in a totally different direction than this is, okay? Okay. But do we have an AT, right? Is AT 0? In this case, in our case, is AT, this is an important question, is AT equal to 0? That is what I was asking you when I was asking, are they braking? Is the velocity changing? So you say the velocity is slowing. So what does that say about AT? If the VT is not constant, then this cannot be 0. Okay? So it cannot be the case. So AT is not equal to 0. Okay? And that means that it's not constant. Okay? Okay. So what that means is there is a little bit of an AT. Now, which direction is it? It's actually not in the forward direction because it's not helping it move in this direction. It's slowing it down, right? So it's not helping it move forward. It's pushing it backwards in a sense, right? This is why in video games you can just press reverse and it's the same as braking, right? Okay. So those are the two directions of the accelerations. It's kind of a lot like now just having a, you know, an AX and an AY together. That's going to give you Together, that's just going to give you a resultant vector that's down and to the left, right? So that's my best guess. If you are answering that question in the way that you said, that it's not 0, that it's not constant, that it's changing, right? Yeah. So if it was constant velocity around the corner, that's kind of a different story, right? Then we're saying that it's constant velocity around the corner, so AT is 0, which means this is 0, which means it's just straight up and down. So it's like there's no AX. So then it's just all AY, and it doesn't look like this anymore, right? And then the answer would be C in that case. It doesn't sound like that's how this is, obviously I'm not reading it in the language that it was written, so I can't give you a for sure, right? Okay, that's how the question says. The figure represents a Formula 1 car slowing down on a curve of a racetrack. Okay. So yeah, I think so. I think it's, I think using that slowing down idea, that it is changing its velocity as it goes, it means that we have to kind of compensate in the vector, right? So that looks a lot like this then. Yeah? Okay, thanks for confirming, Samuel. Rockstar today. Okay, translating for everybody. I'm assuming your buddies are kind of following along here. You're helping them? Yeah? Oh, wait a second, Samuel. Well, okay, so if it was going at a constant velocity, that was a question that we had, right? And we said no, that it's not going at a constant velocity, that it's slowing down. So it makes sense. If this thing was going straight, then it would be A. If this thing was going straight, then it would be A. Okay? But the question is, do they have their wheels at an angle? Right? Because even though they're braking, they are going to continue moving a little bit. Are they going to continue moving along the track, or are they going to continue moving straight? So if they're going to continue moving straight and they don't have their wheel turned, then the answer is A. But I think that they're going to keep moving along the track, right? Which means there's something pulling them, in the diagram, it's down, which means there's something pulling them down. So that is the something pulling them down into the circle, right? But then they're also slowing down. So there's 2 accelerations. So how do we answer this as one acceleration? How do we bring them together? We have to say not just down, not just to the left, but down and to the left. Right? So there is a vector that's pulling me in the direction of the circle. And then there's a vector that is slowing me down. Right? And so I will be pushed down and to the left. Right? Ah, okay. Okay. So, okay, let's do the next one here. I think you know what the answer is, Samuel. Yeah, I think he'll continue the race as well. Yeah, nice. Okay. So, let's see. This one might be a little tougher. This is a little longer. There's a separation between A and B that is 90 meters. And there's two boats each going in each direction. So this is 90 meters, it looks like. And I'm just going to... I wonder if I can do this. Oh god. Oh, it's not so bad. Make this all a little bit smaller. Okay. And then we can zoom in a bit. Okay. Perfect. Perfect. Okay. So, is there any better music? There we go.
Just caught 24K Golden's new video.
No way.
Keep watching, even as
Did
you
it drop yet?
don't miss it.
Alright. There we go. You're still between them? Okay. I think you should discuss it. Take a look at my notes. Okay, so I'll put them in the Discord. Oh yeah, little Chuck Berry. Nice. How do you know that? I didn't know about Chuck Berry when I was your age. Okay. Yeah. Hit him with the next one. Okay. So that's 90 meters of velocity. Okay. I think we've got two kind of boats going. One moving at 0.5 meters per second. The other one 1.5. And 3. Yeah, I'm gonna need a translation, I think, on this one. Alright, Samuel. You're the hero. Translation hero. Give it to me. Hit me with it. We will listen to some Chuck Berry in the meantime. And actually, I'm gonna get our notes in the Discord here. Go, Johnny, go. Come on out. Come on out. Slowpoke. Come on out. Alright, alright. Alright, alright. Alright. Oh no, okay. No worries. Okay, rowers A and B in the figure are initially separated by a distance of 90 meters. The river's velocity relative to the bank. Okay, so the river's velocity, that's what I was not understanding. Okay, so the river this way is 0.5. Oh wait, no, sorry, it's not perpendicular. It's to the right. The river is flowing to the right, 0.5 meters per second. Yeah? Okay. Rower A moves to the right and rower B is to the left with 3.5 and 50 water, respectively. Okay. So, velocity of A, velocity of B. Okay. And I'm going to sort of say B relative to the water and A. B, W, A, W. Okay. Okay. There we go. Is it possible to just get a normal thing here? Just want Normville. Take me to Normville.
Let's get you ready to fight.
What?
Well, multi-platform.
Alright. So A relative to the water, B relative to the water is 1.5 meters per second and 3 meters per second. I think it's in that order. Yeah. Okay. And so this is sort of left and this is right. Okay. What is the distance in meters covered by row A in relation to the shore at the instant when the rowers meet? Okay, so basically the question is sort of like they're gonna meet somewhere, right? So who's moving faster? B, but then the water's hurting them a little bit. But they're still moving a little bit faster. So let's say that they meet. It doesn't have to be, you don't even have to get this right. But let's just say they meet here, right? They are asking, what is that distance there? They're asking the distance there when that's the meeting spot, right? And the water is moving to the right. Okay. So what we need to do is we need to sort of, make this 90 meters or really put these velocities relative to the ground, right? So the velocity, this is sort of, the same thing that you can do when you do this. So if I go from A to B and then from B to C, that's the same thing as going from A to C, right? So when I go from A to B, that's the same as going, sorry, if I go from A to B and then B to C, that's the same thing as going from A to C, right? Well, that's the same logic we're going to use when we say this. The velocity of A relative to the ground is equal to the velocity of A relative to the water plus the velocity of the water relative to the ground. And now This is like AW plus WG. It's just AG, right? And that is what we're looking for. Ah, thank you. VUM today, yes. Some Chicago, listen to Chicago. Okay. Samuel, you're running the stream today. Alright. You got it. Boom. Okay. So A to G is the rower A relative to the ground. And AW, or velocity of A relative to W, is the rower A relative to the water. And WG, the velocity of WG, is WG. And that is the water relative to the ground. That is the current, right? The velocity of the water relative to the ground is 0.5 meters per second to the right. Right? Okay. Nice, Samuel. Okay. Beautiful. So let's just put these here. There we go. Okay. Okay. So that's our sort of like explanation here. This is the equation that we're following, right? And so let's do it. So now we have this value, we have this value, so we can find velocity of A relative to the ground. It's 1.5 meters per second to the right plus 0.5 meters per second to the right. And the velocity of B relative to the ground is going to look very similar. Velocity. So let me just do this. Okay, so the velocity of B relative to the ground, it's going to look like the exact same equation, but B instead. So B relative to the water plus the water relative to the ground. And we'll be able to skip over water and just go B directly to the ground, right? Which is what we're looking for. But here, the trick is that we don't have the same directions, so we have to be careful. So left plus right, we're going to have to do negative left. So actually, it's 2.5 meters per second to the left is the answer to that one. Okay. And now this is the same problem. So what we're just saying here what we've just done is we've sort of turned this problem into a shoreline that's 90 meters. Velocity of A is 2 meters per second this way, and velocity of B is 2.5 meters per second this way. And the water is still it's the same math. Okay, this will be the same math. Maybe let's just do this. Okay. And this is 90 meters. All right. And there's no water, and there's no current. Versus, this is the same thing. Okay. So that 90 meters versus the 1.5 that I had here. And the 3 that I had here, but the current moving in this direction. All right. The current is the river, the flow of the river when it's moving that direction, right? So these two things are the exact same. Okay, so now we just have to sort of ask, what is the distance? So the distance for A is going to be velocity of A times the time that these two have been coming towards each other, right? And that's going to be kind of like this distance. Let's say they meet right here, right? That's delta dA. And so that's going to be the velocity of A, 2 meters per second, times the time. And the delta dB, the distance that this thing travels, is going to be VB times the time, right? And you'll notice that that is the full distance. So that means that those two things added together have to equal 90 meters. Right? And so those two can come together to give us this. And so VA times T plus VB times T is equal to 90. And now we know what VA is. VA is 2 plus 2.5. T is equal to 90. And so we can solve for T. Okay. So 4.5 T is equal to 90. And this is probably good news that, you know, your number ends up being a nice one. So what is this? 200? No, 20. Right? 20 seconds. So they meet after 20 seconds. And then they ask you, what distance has rower A covered? Right? So rower A has covered, well, 20 seconds of, like, that is what they're asking you for, right? And so we now have everything we need, right? Samuel, talk to me. Haven't heard from you. That makes sense? All right. Okay, so then, what's our answer here? Alright. Just doing some rearranging here. Talk to me, Sam. No, 90 meters. It's not 90 meters because that would mean that it's going to go the full way. Is it going to go the full way before it meets B? You should be able to tell me if you and I run at each other and you're running faster than I am. Who's going to travel further? Are we going to meet closer to me or closer to you? So let me ask that question again. This is me. This is you. And I am slower. And you are faster. Right? And you come this way. And I come this way. And we come at each other. Are we going to meet right in the middle? Sorry, my dog's complaining here. Come here. Come here. Come on up. Okay, chill then. Yes, you'll meet me closer, right? Because you're faster, exactly. Beautiful. So you will meet me over a little bit closer to me, right? Well, this is the same problem here. Who is going faster? B is going faster. And remember that we solved their sort of relative velocities. So we could pretend like the water's still and they're traveling at these two speeds. So now you have this problem and this is 2.5 meters per second and this is 2 meters per second. And the full thing here is 90 meters. And then they ask us, what will this distance be? The distance between where you meet... where you start, where I start, and we meet. Right? So, that is... So it shouldn't be 45. 45 is meeting in the middle, right? Should it be less or more than 45? That this number here is. Should that be less or more than 45? What do you think? Thanks, babe. Hey, come here. Come on up. Ah. But we got to be careful because you are going to travel more than 45, right? But then the distance between me and where we meet, the distance that I travel, the slower one, is going to be less than 45, right? you're going to travel more than 45, which means I'm going to travel less than 45. Right? That makes sense? And so the way that we do this is we sort of add up your two distances. So what this is your sort of like my distance. And this is your distance. Right? And my distance comes from my speed and the time traveling. And your distance comes from your speed and your comes from your speed and the time that we're traveling. Right? Okay. And we don't really know or need to find what each of these are just yet, because all we know is that my distance plus your distance should add to be 90 meters. Right? My distance plus your distance should add to be 90 meters. Right? So let me just do that here. Right? Which means my speed, and let me call that VA, and your speed, let me call that VB. So this will be VA times time plus VB times time should equal 90 meters. Yeah? That's kind of like the tough part. And these are our two V's. This is VB. This is VA. Okay? Okay. Samuel, I think if we're gonna keep going, we should jump in the Discord. Okay? Because it's a heck of a lot easier for me to understand what you're understanding, what you're not, if we're talking. Okay? So if you want to, you can jump in the Discord. But otherwise, I can just kind of like do these questions for you. But I think this sort of back and forth is tough. Okay? Okay. Do it. Jump in here. Okay.
Hey, can you hear me?
Yeah. Can you hear me?
Okay, okay. Yes, I can.
All right. All right. So, are you okay, so can you sort of, are you with me here on what we're describing here between me and you running
Okay.
together?
Can you share your screen? Because it
Yeah.
will still have delay on the live.
Yeah. Let me see.
Okay, okay.
Okay. Can you see it okay?
Yeah, I see it.
Okay. So, okay, so yeah, so this is the analogy, right? That we're running at each other, right? And
Right.
you're comfortable saying that we're not going to meet in the middle?
Yeah,
That
because I'm faster than you, so I get a little bit more than 45 meters, I think.
Good, good. But do you agree that the distance that I travel and the
It's-
distance that you travel, they add up to be the total distance, right?
Yeah, my distance plus your distance needs to be 90 meters.
Beautiful, beautiful. Okay, so then are you comfortable with where I get this equation from?
Yeah,
Yeah? Does that make
it's my
sense?
velocity and yours, like.
Well, it's not just my velocity. No, no, no.
Okay.
It's my velocity times the time that I was traveling.
Okay.
What does that make
It's,
it?
it's my mother. Wait, wait.
No problem, no problem.
Falando com o professor aqui, mãe. Tô. É. Tô na número 6 já, acaba na 7. Fala pra ele aqui.
Hello, teacher.
Hello. Nice to meet you.
Ele falou, é um prazer te conhecer.
Hi, nice to meet you. Too. Nice to meet you too.
Nice. Thank you.
Thank you.
No problem.
Sem problema.
Obrigada. Beijo.
Ó, vai dormir?
Pouco eu tô morta.
Tá, boa noite.
Graças a Deus. Agradece aí. Mãe tá agradecendo muito. Você tá me ajudando.
My mother is saying thank you all the time here.
No problem. Yeah, tell her it's my pleasure. It's fun for me, and I
Ele
love
falou
to
que é
help.
diversão pra ele isso. E
É,
ele
sim.
gosta muito de ajudar.
Que a minha melhor amiga mora no Canadá.
My mother said her best friend lives in Canada.
Oh yeah, where?
Yeah. Onde?
Toronto.
Toronto.
Oh really?
Benjamin.
Okay, I'm not too far from Toronto. We
ele
say
falou que
it
ele não
different
tá
in
muito
Canada.
longe
We
de
say
Toronto.
Toronto. We don't pronounce any T's.
Dona do restaurante Rio
O quê?
40 graus.
Hã?
Ela é a dona do restaurante Rio 40 graus. Que
Ele é famoso?
sei.
My mother said she has a restaurant there of Brazilian food. It's called Rio 40 Graus. Like Rio 40 degrees.
Ah, okay. I'm gonna write it down. Can you put it in the chat and make sure that I got it right?
Yeah, I can.
My brother lives in Toronto, so I'll tell him to check it out.
Yeah, okay.
Okay. Who is it? It's her sister?
She said her best friend.
Oh, her best friend. Okay.
Yeah,
Cool. Rio 40 degrees?
like this. Mas o restaurante é Rio 40 graus ou degrees? Tipo, degrees é grau em inglês.
É grau de frio. De temperatura.
Eu sei, mãe, mas em
Eu acho que deve estar escrito em português. Não sei.
ou é o símbolozinho?
But if the name's in Portuguese, then I'll look it up in Portuguese and it'll work.
Okay.
You don't translate it, because then I won't find it.
Okay. I sent it.
Okay. Where? Oh, in the general.
At the
Okay,
general
okay.
chat.
Perfect. Okay. I'll look it up.
Okay.
Okay. Is it good? But listen, my brother is a vegetarian. Is it
Okay.
It's specialty in meat or what?
Yeah, Brazilian food has a lot of meat, so he probably
I
doesn't
know
like the
this.
restaurant.
Yeah.
Não, ele falou que o irmão dele é vegetariano, então provavelmente não vai conhecer muito de comida brasileira porque só tem carne.
That's okay.
Tá, eu vou terminar logo aqui a
Tá
prova,
bom,
mãe.
tchau.
Tá no número 6, vai terminar na 7.
Deixa eu dar tchau pra ele.
Tá? Fala bye.
Bye, teacher.
Bye.
Good night.
Have a good night.
Tchau.
Okay, so let's jump back in.
Okay.
Okay, so this equation, it's not just velocities. Yeah?
Right.
It's velocities times the time. What happens when you multiply a velocity by a time?
Get the distance.
Yeah, so that is the
Okay.
distance of A.
And the distance of B.
Yes. And then we're adding them together and we're saying
Right.
that it's equal to 90 degrees, right? Do you agree based on, what the story is here? That they should add
Yeah,
up
I
to-
agree.
Okay. So then, let's just be careful because the velocity of A, remember, this has to be like you looking at the boats, not you in the boat, because you'll think that you're going faster than you are because the water is moving too, right? Have you done this?
Right.
Have you been in a boat when this is happening, or have you swam in the water when this is happening?
Yeah, a lot of times.
Okay, right?
Here I live so near the beach here, so
And
all
is
the
it
time.
is there a strong current?
Hmm?
Is there a strong current? A strong the water moves on its own really fast, or is it mostly still, or mostly like coming in to the?
You mean like if the water here in the beach is like
Does it move
slow
sideways?
velocity or
Does it move sideways? Not just waves
You mean the
coming
waves?
in and out. Yeah.
okay,
like-
the waves are small here.
They're
where I
small.
live.
Okay. Okay.
But we have a house in one beach here that it's with big waves. Do you know Copacabana? It's the most famous
Yeah.
beach here.
Yeah, of course.
Yeah, we have an apartment there.
Oh, wow. Okay, nice. Okay.
Yeah.
So you know all about this water relative stuff, yeah?
Yeah.
You know you can swim very slow, but if you're going with the water, then you'll end up going fast because the water's going fast, right?
Right.
And if you're going against the water, then
You get slower.
you go slower. Your velocity gets canceled. You get subtracted from the water's
Yes.
velocity, right?
Right.
Okay. So that's what we're doing here. We're sort of saying, you know, this 0.5 of the river, it's going to add to the ones that are going in the same direction. So who's going in the same direction as the river? A or B?
The one that is going faster.
Oh, careful, careful. Your options are A or B.
Okay, so I would say it's B.
Why? Is it
'Cause
going...
It's the one going faster.
But this is what you're talking about is a faster swimmer. Two swimmers and one's faster, right? What I'm
Right.
asking about is who is swimming with the water, who's swimming against it. I might be able to look like I'm going faster, but I'm going against the water, right? If I can go fast
Okay.
enough. Do you agree with me? That if I
Yes.
can swim fast enough, I can go just as fast as you against the water as you are with the water. If you're just coasting, if you're going really slow, right?
Right.
So it's not about who's the faster swimmer. It's not about who's faster. It's the direction that you're going that matters, right?
Right.
Are you in the same direction of the water or are you in a different direction of the water?
If I'm faster, I'm in the same direction.
Careful though, careful.
So I'm against.
Getting faster. Yes, I agree
Okay.
with you. But when we compare two boats, A and B, B is just going this fast. It's just going 3 meters per second, right?
Right.
But it's going in this direction.
Right.
And A is going in this direction, right? So if we forget
Okay.
about who's faster, which one is going with the water?
the letter A.
Yes, because it's in the same direction as the water, right?
Okay.
That's what matters. So you will get faster. I think this is an English language thing, okay? Because the word faster means two different things in this context, and it's very subtle what I'm saying here. But you
Okay.
get faster, meaning your water speed increases because it gets added to this water, right? The only
Alright.
reason you add them is because they're in the same direction, right?
Okay.
So that's what matters. They're in the same direction. Okay, so what did we do with the A? We added it to A. And then because B was in the opposite direction, what do we have to do with the 0.5 to B's direction, or to B's velocity? Should B get faster or slower if it's moving to the left?
Should get faster.
Why? It's moving to the left. Which way is the water moving?
So it should be slower.
Yes, right? If I'm moving this direction and the water's moving this direction, I'm going to get slower, right?
Right.
And so this is the situation for B, right?
So letter A is getting faster because it's going with the water.
Exactly. Yeah. Exactly. So it doesn't matter. So this is why it's, 1.5 plus 0.5.
Right.
And this is why this one is 3 minus 0.5. That's what's changing, right? Is the plus and the
Yeah.
minus. And it's because of the directions, right?
Right.
But if this was 4.5, it would still be plus, and this one would be the higher one. So it's not about who's higher in terms of number. It's about whether they're in the same direction or not, right?
All right.
Okay, so then that's where we get our 2 and our 2.5 that we end up using in this equation. Okay? So that's what our velocity of A and our velocity of B are. Remember, this was our, you know, my distance
So-
plus your distance is going to be 90 meters.
And it's all happening in 20 seconds, right?
Do we know that it's happening in 20 seconds?
I
Yeah,
thought-
we solved right here. So this was us saying your distance plus my distance is going to be 90. And then we took this equation. This was the equation here. And we plugged in these 2 and this 2.5. We plugged it in, 2 and 2.5. And then we solved for t. So we rearranged and we solved for t. And we got t is 20 seconds. Okay.
So it's 2.5 multiplied for 20. Oh no.
What's that? Say it again.
We take the 2.5 meters per second and multiply it for 20.
Oh yeah, but remember that's B, right?
Oh, okay. And he wants letter A.
Well, do they want letter A?
I don't know. Let me see it there.
Yeah, check the question here.
Okay.
It's always good to check back with the question because
Yeah, he wants letter A.
Yeah.
But it's related to the, I don't know how to say it. Do you know the?
it's relative to the shoreline.
Yeah, that's it.
Yeah. So that's what we're saying here, which is like, you know, you are gonna see this rower actually go this fast and you're on the shoreline. So that's what those 2.5s are. That's the speed relative to the shoreline. Okay.
Okay.
And that's this idea here, which is basically A to B and then B to C is the same thing as going from A to C, right?
Okay.
Well,
Yeah.
that's what we do. We go from rower A to the water, and we add that to water to the shoreline, and we will end up with A to the shoreline. So we can kind of like cancel the W's out, just like we canceled the B's out here, right?
All right.
So that's the sort of what we did in these equations here was we said BG comes from BW plus WG, right? And then the W's kind of sandwiched together and we end up with just BG. And that's what each of these mean. They mean relative to the water, or water relative to the ground, or rower relative to the ground, or which is the same as the shoreline. Okay?
Okay.
So that's like kind of really making this is the same process as this, but this is the like very visual version of it. But this is the sort of like equations you might need to prove it. Okay, but look, we get to the same numbers, 2 and 2.5, and here, like this is 2.5 to the left, right?
Right.
And this is 2 to the right. Yeah, and that's what we get here. Okay. So yeah, and then so yeah, you were saying instead of, so you were sort of giving me VB, the 2.5 times the 20 seconds. That's the velocity of the B relative to the shoreline. We want the velocity of A.
Letter A.
Yeah, relative to the shoreline. So we want to use the 2 instead of the 2.5 because the 2 is the relative velocity of A.
Of letter A.
Yeah,
Okay.
exactly.
So we take and multiply it for 20.
Yeah, exactly. Yeah.
So it's 40 meters.
Yeah. And is that consistent with what you thought, that it was going to be a little bit less than 45?
Yeah, a little bit than 45.
Beautiful. So that's important. That's you know, your guess of you've lived in a physics world for your whole life now, and you have a lot of instincts about movement and about speeds and stuff. So use your instincts that you know of from that stuff, right? Like when we simplified the problem, you could tell me for sure that this is going to happen not at the middle, but closer to me, right?
Okay.
And so your 45 like makes sense with that. Or sorry, your answer of 40-ish meters, right? And so what if,
So I got right.
well, let's check. Let's check. If we had accidentally done this, right, which is what you wanted to do, the 2.5 times the 20 seconds, right?
Oh,
Then,
it's not 2, but it's 2.5.
well, wait, this is what you said at first, right?
Okay, okay.
Do you remember?
Yeah,
And so what do we get? We get 20 times 2.5 and we get 50 meters.
right.
How would you have felt about 50 meters based on what we said?
It's wrong because we need to get a little bit,
Right.
a little
Exactly.
bit, and yeah,
Exactly.
we have, yeah,
Right.
yeah. It needs to
So
be less than 45 meters.
exactly. So even if you do make the mistakes, zooming out a
Right.
little bit and then sort of like using what you know, using your instincts, you can kind of solve that. Oh wait, no, sorry. And you can even tell if I tell you this is 50, you could probably tell me, oh, they add to 90, so then it's 40, right?
Yeah.
And so
Okay.
you can get to the right answer even by using the wrong answer in some way.
Yeah, because it doesn't make sense, right?
Yeah, exactly. So always check. Like with physics, you have so many ways to check because you've been living your whole life in this world without knowing it.
Okay,
Right?
okay.
Chemistry, okay, yeah. Atoms, yeah. You don't have any experience. You've never thrown things, right? That like that, right? But like physics, you've thrown things. You've been in cars. You've done all this
Yeah,
stuff,
yeah.
right? So use that experience. Okay.
My father likes so much cars.
Ah.
We have a Mustang, do you know? The car?
Oh yeah. Wow.
Yeah, yeah.
Nice. That's great. What year?
It's 2010,
Oh.
a GT.
Nice. I think that's
It's
actually.
4.6. It's a V8.
I don't even know what those things mean. I see. I ride a bicycle, so my
Oh, okay.
knowledge of cars is pretty low.
Okay.
Okay, wait. Let's. You want to do number 7 here?
Yeah, we can do the number 7.
Okay.
Right. I'll get it. Wait.
Here, I got it here. Okay, I'm
It's
gonna
here.
need your
I
translation.
just need to translate it.
Yeah.
The only problem is because I need to type all the questions because I can't do a Control C, Control V here.
Yeah. It's because it's a picture.
Yeah. Kit? What? Okay, I'm getting it.
Okay. Um. Okay. So at least we have a couple velocities that we can mark down here. Start the process. Something's 10, something's 5.
Okay, this is the title of the question.
Okay. Boat travels in still water at a speed of 10 kilometers an hour will be used to cross a river which current has a constant speed of 5 kilometers an hour. Okay. So
Now I'll get letter A, B, and C.
sure. Thank you. Okay. Hey, stop. Okay.
Okay, this is letter A.
Okay. If the boat positions the boat perpendicular to the banks and across the river, letting the current carry on what angle the church they follow makes the okay. So we're sort of saying if they point in this direction, right?
Okay.
So that means like perfectly perpendicular from the shoreline. If they point in that direction, but the water's pushing them in this direction, which direction are they going to go?
Down.
Well,
Okay,
they are going
no,
to.
if the water is going, if the water is going to right.
Yes.
But if it's going down, we go down to the right, right?
Yes. So their boat is going to try to move downwards, but because the
Right.
water is also moving, right? They're
Right.
going to sort of, as a net, they're going to move down and to the right. And so they're going to move down and to the right. Yeah?
Okay.
Okay. So let's say that we can draw a vector then that kind of represents that motion, right? That's
Right.
that vector there. And the green vector here is our velocity of the boat relative to the water. That's the boat trying to trying to cross the water, right?
Right.
So relative to the water means like if you're in the boat and you're not looking at the shoreline, you're just sort of thinking that you're moving, across the water perfectly, right?
Okay. Right.
Okay. But then the water itself is moving relative to the ground, right? So when I
Right.
put the letter before the V and then after, what I'm saying is boat relative to ground. Sorry, boat relative to water. That's the W, right? So the velocity of the boat relative to the water, and then the velocity of the water relative to the ground. Okay?
Okay.
So, sorry, I've got my dog on my lap and she's moving around. Okay, stop. So, okay, so then that is the vector that gets added to that, right? This is like a 90-degree triangle that we've done a billion times. And so this is the velocity of the boat relative to the water. That's the velocity of the water relative to the ground, or really just the velocity of the water, right? And so then we get velocity of the boat relative to the ground. Okay. And so we can add these two up and we can use the right angle triangle math. So this is, what is that is a size, and what is that as a size?
You mean what direction?
No, what number?
Okay.
How big is
This is
it?
number 5.
Which one? Sorry, is A here? Is that A and B I'm asking about? So who's 5, A or B?
I think B.
B is 5. Yes, good. That's 5. And that's 5 kilometers an hour, right?
Right.
Good. Okay, what about A? Straight down.
I think A is 10.
Good. Okay, let me ask you this. Will that number be bigger, smaller, or the same as 10?
Same as 10.
It's going to be 10 also?
Yeah, I think. Okay, it's bigger than 10.
Why? Not because of my reaction. Your reaction should be the same.
Yeah, okay.
This is a right angle triangle.
Okay.
The hypotenuse, this side, I don't know if it's the same in Portuguese, but hypotenuse is what we call it in English. This always has to be the biggest side. It has to be bigger than 10.
Oh, okay.
Yeah?
Okay.
You with me?
Yeah, we call it hypotenusa.
Okay,
Yeah.
very similar, right? Okay, so so this is going to be you know, the square root, right? We've got to do a squared plus b squared equals c squared, right? So
Okay.
we're going to do c is equal to the square root of a squared plus b squared, right?
So it's like
Who's a, who's b? Have you seen this
A,
one?
it's 10 kilometers per hour,
Yes,
and
good.
B is 5 kilometers per hour.
Good. So then, what's the square root of 10 squared plus 5 squared? It's the square root of 125, which
So-
is what, like 11 point something? 11 point.
I
One.
need to see here. Yeah, 11 point something.
Yeah, 11.18, right? Okay, and that's kilometers per hour. Yeah?
Okay.
Okay. So what do they ask? They ask, what direction will they have to aim, or will they end up? Right?
Yeah, I
Hey,
think.
stop. What direction will they end up if they're gonna kind of like they're gonna try to go directly across, but they're actually gonna end up at an angle, right?
Right.
So they ask kind of like, what is that angle? And do they ask us about theta, or do they ask us about alpha? Which one do they ask us about?
Alpha?
Yes, because they say relative to the bank, relative to that, right?
Mm-hmm.
Okay, good. So then, okay, so then let's solve it really, right? Like, let's kind of find this value, and then we
About the
can,
angle, right?
and then we can find that value, right?
Yes, it is asking for the angle.
Is
Right.
it?
Yeah.
Yeah, it is. Yeah. Good. Okay, so then, how do we get to the angle there using 10 and 5?
We need to know the hypotenuse.
No, don't need to know the hypotenuse. Angles, the
It's-
angle isn't in the Pythagorean theorem, right? So in English, we have so, ka, toa. I don't know if there's a similar
Okay.
sort of thing.
I think we have the same here.
Yeah?
Yeah.
So sine of theta is opposite over hypotenuse.
It's yeah, we have
Yeah?
it. It's seno, cosseno, e tangente. That's what we
Okay,
have.
beautiful. So this is what ours look like. So which one are we going to be doing? Who should we use to try to find theta here? We have 10 and we have 5, right? So which one is
Right. Yes, I forgot all about these things.
that? Oh gosh. Okay. Okay.
Yeah, I studied, I think 2 years ago I studied that.
Okay, and that was right when COVID hit, right? So we can't
Yeah.
even count it. Okay. So for us, it's opposite, hypotenuse, and adjacent. Those are our three options. Okay.
Okay.
Adjacent means next to it. So this one here is next to the angle, and then this one here is opposite the angle, and this one here is the hypotenuse of the angle, right? Or
Okay.
the hypotenuse, right? It's always hypotenuse. Okay, so we have the opposite and we have the adjacent, right? If we didn't solve for this, then we wouldn't have that, but we did solve for it. So we could actually use any of them. Okay?
Okay.
So let's just use the one that we kind of would use from the start. We would use tan because we have the opposite, the O, which is 5, and we have the adjacent, the one next to it, which is 10. Okay?
So it's 0.5.
Yeah, so the tan of theta is 0.5, but that's not the angle, that's the tan of the angle. Right?
Okay.
It's close, but it's not quite the angle, right?
Right.
And so we have to then ask our calculator, hey, can you do the tan inverse for me of 0.5, right?
Right.
So tan to the -1 of 0.5, and we get 26.6-ish degrees. Okay. And is that what they were asking for?
Let me see. He says, if the boatman positions the boat perpendicular to the banks and crosses the river, letting the current carry him, what angle will the trajectory followed make with the bank?
Okay, with the bank. Is that angle with the bank?
No, I think.
No, that's theta, right?
Right.
We need to find alpha. You said we have to find alpha.
Yeah, but we found alpha, right?
What is it?
Hmm?
What is it?
We found alpha.
What is it?
Okay, okay. We need to get beta.
No, we have theta. Look, we have theta, right? Because look, this was the angle that we had there, right? That one was the one that was in the triangle. So that was the one
Okay,
that we used
so
the SOHCAHTOA
now
with.
we have to get alpha.
Yes, yes.
Oh,
So how do we find alpha? How do we find alpha?
You mean the formula?
Well, I mean, sure. I mean, if there's a formula, but what would we do? What would you do if I gave you that that theta was 26.6? What math would you do to find alpha?
You need to. I think you need to get a like it has a maximum value, right? I don't know. Like,
No, there's something
'cause-
special about alpha and theta. They're related to each other.
yeah, I know it. It can like one plus the other need to get like 80 degrees or something like that,
not
right?
80, not 80.
Not 80. It's
Not 80, it's
180.
90. 90 is a right angle.
Okay, 9.
Right? 90. Talk to me. What?
Okay. I just remember about the part that the one plus the other need to be some angle, but I forgot the angle.
Okay.
Okay, now I
okay.
know.
Cool. Okay, yeah. So when it's a when they say perpendicular, right, that means they're gonna add to be 90. Right?
Okay. So it needs to be 64.4 degrees, right?
Yep. No, 63.4.
Yeah, right.
But I mean, you could do that with your calculator, right? You could check that. That's not so scary. Okay. So then it's 90 minus theta, right? Beautiful. Okay. And then what about part B? What does it ask in
Okay,
part B?
I need to get it.
Okay,
I'll translate it.
I'm gonna try to interpret here. They want to travel directly across. So what angle should they aim? So what it says?
Well, I need to see it. Wait.
Wait, let me ask you. So read it, and then I'll ask you and you can translate both in your head. Okay.
Okay.
Okay. So let me ask: is it the boat person wants to now go directly across the river, and it's asking what angle should they aim at?
No, it's like if the boatman wants to cross the river in a perpendicular trajectory
Yeah.
related to the bank,
Yeah.
which angle he have to stand? I think stand like
Yeah. Aim, I think, is what we would use. Like point. What bearing should they
pointing
use?
to the bear
The boat.
to the boat.
Okay.
But I'll check it right here with Google Translator. Wait.
Sure.
Okay, I sent it. Oh, I sent it in Portuguese. Sorry.
That's okay. Don't worry about it.
Okay.
I think I know the question. Okay. So, can we agree that the arrow I've drawn here is the direction that you want to travel? You want to travel perpendicular to the bank, right? Which means
Right.
90 degrees to the bank, right? So you want to travel directly across. You want to not move either direction. Yeah? You want to go
Right.
directly across. Okay. Now you've done this thing. You live by the beach. Tell me, if you were leaving from the green spot and trying
Okay.
to go down, which way would you aim? Because we just saw what happens if you aim
okay.
straight
Yeah.
across, right? You get
We'll-
pushed.
I would get pushed to my left.
Well,
'Cause
you would like sort of swim to your left so that you got pushed,
Yeah.
right?
Yeah.
Okay, yeah. I think that I understood what you mean, right? You would aim over here,
Yeah.
right? And that way the water kind of pushed you perfectly straight across, right?
Yes.
Okay. Well, this is the same sort of addition, right? It's going to be a triangle, but we're going to have to be careful, okay? Because
Okay.
now the triangle looks like this. It's your aim, right? The way that you
Right.
try to go, just like this one was the green one, was the way that you try to go. So let me draw that in green. It's the way that you try to go is the green one, right?
Okay. Right.
And that was what we did here. That was the green one, right? And then
Yes.
to that, we add the water. We added the water on top of that one, right?
Okay.
Here. So let's add the water on top of that one here. Well, let's add the water on top of this one. There. And now what do we get? We get perfectly straight down is the result when we add them together, right?
Right.
So it's green plus, let me just write this as sort of like this. Green arrow plus blue arrow equals purple arrow. And that is the same thing as what it was here, right? I drew this one in
Right.
black, but it's the same story. Let me just put it in purple. And that was the same story, right? Green plus blue equals purple, right? And so
Right.
the equation is going to look very similar, but we're going to have to be careful because our math is going to look a little different, right? Now the green one was smaller than the purple one here, right? Purple
Yeah.
was bigger. So who's going to be bigger here, green or purple?
The green.
Green's going to be bigger, right? So
Right.
purple should actually look smaller.
Yes.
Okay, so then I tell you now, sorry, so wait, what is green? Green, remember, is how fast you can go on your own. How fast can you go on
Yes.
your own?
When I jump the water.
When you're just in the water. When you're just
Yeah.
you in the water. Not the water moving, but just you in the water. How fast can you go?
Yeah, that's the green, right?
Yeah, but what is the number?
10.
Yeah, you can go
Okay.
10, right?
Yeah.
That's how fast you can go. 10. And how
Right.
fast is the water going?
5.
Yeah. So wait, how is this not the same triangle? Because this triangle has 10 and 5 in it, and it's a right angle triangle. How's it different?
Is it different because 10 is the hypotenuse?
Yes, good. Good catch. So now this better be smaller, right?
Yeah.
Which we said it has to be, right?
Right.
So that makes sense. So that's good. At least, you know, Pythagoras agrees with us here. Okay. So then, what do we asked for B? What angle should they keep? Okay, so now we can just ask the boat. And do they ask the angle to the banks? Alpha or theta? Which one are they asking about here?
About theta.
They're asking about theta. So let me just see. At what angle should he keep the boat facing? Yeah, I think that it does ask about B. Or about theta.
So it's
I do think it
okay.
does.
So it's he's asking about alpha.
No, I think it is theta. I think it is theta.
Oh, okay, okay, okay.
Yeah, it's hard to tell because I think, like, does it say relative to the bank?
Let me see.
What angle to the bank? It does say
Yes, if
about
the boatman if the boatman wants to cross the river on a path perpendicular to the banks,
yeah.
at what angle should he keep facing the boat? He asks about the angle that
Okay,
the
so then
boatman should keep facing the boat.
okay,
That's it.
so I could tell you, I could get you in this direction both ways. I could use alpha, but I could say alpha from the bank, and in that case you'll start at the bank, which is the horizontal, and you'll move alpha away, right? And you'll get me to
Okay.
that spot. So I could say that. So this in this way you can actually give either answer to this question. So you can say alpha from the bank. In that way, you're telling me the direction. Or you could say theta from perpendicular.
Right.
Right? Because then that's the same spot. Even though theta and alpha are not the same, you get me to the same spot because this one you say from the horizontal and this one you say from the vertical. So either or is okay here. These are both the same. Okay? So I think they just say, like in the first one, they said relative to the bank. So we better tell them, you know, relative to the bank. We should be giving them alpha, right?
Right.
In the first one, in A. But in the second one, they just say what direction and say, okay, so I could point you in the direction by telling you either of these things. So it's okay. I think either one is going to be okay. Okay.
Okay.
So let's solve for, I mean, theta is probably the easier one. So let's solve for theta. Okay, so remember what we did for theta last time? We used SOHCAHTOA, right?
Okay, so we are gonna use it again.
Good. And
Okay.
who do we have of O, A, and H? Let's maybe try to label O, A, and H for theta here.
We have H.
We have H for sure. And
Yeah, because it's 10.
good. And
And we have this letter O.
right, which is the opposite. Okay.
Okay.
It means it's kind of like opposite it, right? Because these
Okay,
it doesn't
right.
touch that one, right? Okay, so it's 5. So it's opposite. So this for us, oh, sorry. For us, it's going to be sine of theta is opposite over hypotenuse, right now, which is the same as 5 over 10.
That will be again 0.5.
God. Yeah, exactly. So the sine of theta is 0.5, and so theta is 60 degrees. No, sorry, 30 degrees. Okay. Well, I mean, you would ask your calculator. This isn't something you're supposed to know, maybe, so you just sort of say sine inverse of 0.5.
Okay.
And you get 30. Okay?
Mm-hmm.
Okay, so how would you say this? You would say go from directly across, go to the right by 30 degrees. And that way the water can push you to the left. Right?
Okay.
So that, I think you would just put that into a sentence. Okay. Okay, what about C?
Wait, so we got 30 degrees as the answer, right?
I don't know, you tell me. Is it?
Yeah, that's in my mind. That's the final result. But
Yeah, exactly. That's the angle that we need to aim, right?
right.
Okay. Is this stuff is it coming a little bit clearer?
Yeah, I think yes.
Yeah? Okay. Cool.
Let me get
Glad I could
the
help.
letter C.
Yeah, absolutely. Okay. Okay.
Okay, in which case will we take longer to cross the river?
Okay. So, in this case, like the velocity that matters for crossing the river is the one that goes directly across, right? So we
Right.
never actually found what the velocity would be here. Could you tell me what equation I would use to solve for the velocity there?
How to solve that velocity?
Yeah, which equation would I use?
We should use that SOHCAHTOA again.
Well, not SOHCAHTOA because there's no angle.
Oh, okay.
So it's a squared.
Plus b squared equal c squared.
Beautiful. And who's who? Who's A, who's B, who's C?
A, it's the 5, and B, it's the 10.
Ooh.
Okay, A is the 10, and B is the 5.
No, no, no. Who
okay,
is...
A is the one that we doesn't have.
A is the one we don't have, okay.
And B is 10.
B is not 10, no.
Okay, B is 5.
B is 5, okay.
We
Why?
don't have 10, and we have... And
Who's...
wait.
Who's 10?
We don't have letter A.
We don't
10
have
is
A.
letter C.
Yes. How do we
And B
know?
is letter 5. Oh.
How do we
C
know?
is...
How do we know that it's not C is 5 and B is 10?
Because it's just a logical thing.
No. Not enough, because that's like telling your brain, come on, brain, work, right?
Okay.
So it doesn't really work that well, right? But
Okay.
if you sort of stop it from going places because it makes sense, then that's a lot better. So let me ask you,
Okay.
which side is bigger, the left side or the right side?
The left side.
No, that was a trick question. It's an equation. They're equal. That's the whole point. It's an equal sign, right?
Oh, yeah. Okay.
It's an equal sign, right? Okay, but now let me ask you this. Who is bigger, green, blue, or yellow?
Yellow.
Yellow.
Yellow, it's the hypotenuse.
Well, okay, but how about this? Let me just do this. Yellow is equal to green
Plus the
plus blue. Who's bigger, yellow, green, or blue?
Yellow, because yellow is same of green plus blue.
It's both of them added together.
Yeah.
So
yellow
however
is the bigger.
big green is, it still has blue on top of that, right?
Okay.
So yellow is always bigger than either of these two, right?
All right.
Okay, so that's how you remember that C is bigger. C is always bigger because It has to be bigger than one. Like, it can't be the biggest one is here, and then you add something to it and you get something smaller. No, that doesn't make any sense, right?
Okay.
So this has to be the hypotenuse, and then it actually doesn't matter who's A, who's B. This could be A, this could be B, or this could be B, and this could be A. It doesn't matter. Okay?
Okay.
Okay. But, okay, so now, I'm done, berating you. So let's say B is 5 squared, and this is 10 squared. Yeah?
Okay.
So A squared is equal to... ten squared minus 5 squared. Oh.
125 again? Oh.
It's minus this time. Right?
Oh, okay.
Because this, so here, let me do this. A squared is equal to 10 squared is 100, and 5 squared is 25, and then it becomes a minus when we move it over to that side.
Oh, okay.
Right? And then we square root 75. So it's a little bit bigger than 8. Right? A little smaller, so it's like 8.5-ish. Square root of 75. 8.6. Oh, no, 8.66. So 8.7. And so that is A. Yeah. Okay. Now, the reason that I wanted to sort of get there to that point, to that question, is because it asks about who crosses the river faster. Well, what matters is the velocity that you're crossing the river with. So for us, the one that's going perfectly across in this scenario is our 10,
Okay.
right?
Right.
And what's the velocity that's going perfectly across in this scenario?
The 10.
No. The 10's going on an angle
Okay. Oh, okay, okay. The purple because it's going all
directly
down.
across, right? So even though
Okay.
this one wasn't the purple, the one that's going directly across, it's kind of asking you how fast are you going directly across? So all you need is the vector that's going directly across. Okay?
Okay.
If I was asking you how far are you going horizontally, all you would need would be this vector. Okay?
Okay.
So, okay, so who's bigger, 10 or 8.7?
10.
That's it.
Okay.
You're done.
Oh, okay.
So who's
10.
bigger?
Okay. 10 is the answer.
Yeah.
Oh, okay. That one was more simple, I think.
Yeah, exactly. Yeah. So it's just about kind of who's
What?
going faster across the river, right? So it says, in which case will it take longer? Well, careful. Which one will it take longer? We said 10 was the faster one.
Oh,
Right.
okay.
So-
So it's the purple one.
Well, B, right? They're talking about A or B, right? Is it A or is it B that's faster?
The faster one is C because it's all things, right?
Wait a second. C wasn't a scenario. C is the question, which one's faster? So there's only A and B, right?
Okay, so it's B.
Why?
Because
Why
it's
is it faster? What are you going to point
Because-
to say it's faster?
Because it has a bigger velocity.
Well, why? What is its velocity?
Because it's 10, right? 10 kilometers per hour.
No,
And the
not
other one is 8.7.
no. That is so A and B. This is B. This is A. The A is the scenario where you're not going directly across, where you're going on an angle. B is the scenario where you're going directly across and you're aiming on an angle. So this is what they're sort of asking about. They're asking about going directly across.
Okay, so B has less velocity, but it's going directly. so it's faster, right?
Wait a second, wait a second. Let me write this here. So this here, this here, this. Okay. So this was the scenario from B, and this was the scenario from A. Right?
Right.
Okay. So I switched it to be a little bit, to be vertical now, kind of, or to be the other way around.
Okay.
But basically, we aim, right? We aim this way, and this is the way you actually go, and this is the way you actually go because this was the way that you aimed, right? So you aim, and then the water affects you. The water pushes you in a certain direction, and so it's the way it goes is it's aim plus water equals go. That's how I've written it here. Right? Aim
Right.
plus water equals go. Okay. So the question is which, in A,
Oh, okay.
which vector is directly across the river? Is going...
The black one.
No.
Oh, okay.
Look. That is on an angle across the river. That's not directly across the river. Who's going directly across the river?
Oh, across, you mean like to the other part?
Perpendicular. Perpendicular. Who is going perpendicular? Is it
The green one.
the green one? It's the green one, right? And that
Okay.
green one was 10 kilometers per hour from that
Right.
triangle, right? Okay. And now who is the vector going directly across here in this scenario? Now it's not the green one. The green
In
one's
letter
going on an
B,
angle.
it's black one.
Yes, good. And that one was the one that we calculated to be not...
8.7.
Yes, now you're with me, Samuel. All
Yeah.
right. I like it. Okay, I gotta close this program for a second. So it gets too big. We'll open it up. Okay. Okay. So then...
You
yeah.
need to share screen again.
Oh, yeah. Sorry. Okay. Okay. Cool. So, yeah, so we say the velocity, the velocity 8.7 is the one going directly across,
Okay.
right? So who's faster? That's what they ask you now.
The faster one is the green one because it's going 10 kilometers per hour.
Good, but careful because green is kind of in both, right?
Oh, okay.
So tell me the number of who is faster. The 10
You
kilometers.
mean the letter?
The 10 kilometers an hour, right?
Okay.
Yeah.
And
A,
the letter
A,
B?
A, right?
Okay, A.
Why B? Why did you say B?
Because I would ask you if you were talking about A or B.
Oh, okay. So, I mean, to answer who's faster, you said the green one, right? And that's
Right.
that's from A. That's scenario A.
And
Right.
in letter B, the black one is the slower one.
Yes. So now the
Okay.
question is not who's faster. I think the question was who takes longer. So really the question is who's slower.
Okay, so the slower,
Yeah.
right?
Who's slower of
It's the
those two
black
speeds?
one.
Yeah. Perfect.
Okay,
Okay. So then that's scenario B.
okay.
Boom.
It's the slower one.
Yeah. It's the slower one. It will take longer. The slower one will take longer, right? Okay. Is that all of it? Because on the page, that was the last question, right?
Yeah, but how can I answer it? Like, I don't know how to answer it. Just
Okay.
I have the result that it's 8.7, but how would I say it? Because
Well,
yes, in which of these two cases would take the longest time? So
okay.
he's talking about letter A and B, right?
Yeah, exactly. So which one will
So
take more time?
letter B.
There you go. That's your answer.
Okay, so I just answer writing letter B, right?
Yeah. I mean that it depends on if your teacher wants full sentences or not, right? Like so this is now particular to your teacher.
No, I know. I just mean
But yeah, the
how
answer is
to
B.
say it.
Yeah.
Yeah, okay.
That's what I would put. Like simple enough, I would just say B, right?
Yeah.
It would take longer. Yeah.
I was so confused about this test because I need to get like 5 point something in this test. It's the last test of the year. Like,
Mm, okay. Cool. Yeah, it's definitely there's a
'cause-
lot of tough questions on here. Yeah, for
yeah,
sure.
and
Um
like
so this is
because
the last
in
one.
the yeah in
Oh
the
my god.
first test I got 5 because I just got in the school,
Mm.
and the median of the school is 6. We have to take 6. And the
Ah.
second test I got 7.8, so I'm still in the median. So
Okay,
if I
okay, you're
get like
average. I see.
5.2, I can pass the year without recuperation. That's how we call it here.
Right, like having to take it again or to add
It's
time to make
it's
it up.
not we can go to the second year of high school without making the
Ah.
final test. We have a final test.
Okay, you have a test every year in high school?
No, we have three three. I don't. Let me see how to say it.
Yeah.
Right. Okay, we have 3 quarters. That's
Yeah.
how it's say here,
Yeah.
or trimester. I don't know how to say it,
Yeah.
but we have 3, and in each trimester we have some tests of each job in school.
Okay.
Okay,
Right.
but my school it's with online classes. I'm not
Yeah.
going to school.
Yeah.
I don't know why. My school is like one of the Unix one that it's
Oh, really?
doesn't got the presential classes.
Okay. So it's
I
all online.
like yeah,
Mm.
we just study online and make it online tests.
Wow.
Look, I can show you. Look, can you see my screen?
Let's see.
Can you see it?
Mm. Yeah.
This is the platform we use in school. Look,
Oh, right,
this
right,
is
right.
the test, and this
Yeah,
is
yeah,
the
yeah.
my teacher. Like,
Right.
so we have all these jobs in school. It's
Oh
not
my
like in
gosh.
Canada or United States. I think they just have 3 jobs at school or something like that.
In when I went to school, we had we instead of trimesters, we had just the full year and we had 8.
Okay, yeah. But my school is different because it's a technical school. So
Mm.
when I finish school, I am a mechanic too. You know, I do
Oh,
industrial mechanic at school.
nice. Wow. That's
So we
great.
have biology, chemistry, we have English,
Yeah.
but school English is not so good. You know, I did 8 years of English. I did a course.
Your English is great.
So,
What do you mean?
hmm?
Your English is great. What do you mean?
No, I said I learned in English with an English course. I
Yeah.
didn't learn with
Oh,
school. So in
okay.
school, English at school, it's
It's
easy for
different.
me. Yeah,
Yeah.
all my friends asking me for answers.
You've got to be the whiz
Yeah,
kid when it comes to English, huh? Did
and
you?
this is industrial medition. I don't know how to say that word in English. Let me see. Okay, machining.
Oh,
We
machining. Oh,
have
cool.
Portuguese, physical education, history, mechanic, material science, math, technique, geography, philosophy, sociology. I think that's how we call it, and
Yeah.
physics.
Wow. So you're doing these all the
But
same, or this is like all the trimesters, Or this is just
This
one?
is all the trimesters we have here.
Okay.
So this is my tests. Look, I need to
Okay, show me.
look. Physics is I need to
Oh, okay.
send to the teacher Friday. Portuguese Friday. Industrial medition Friday. Technical draw 15th. I don't know which day it is, but like I think it's Monday, Thursday, Wednesday, Thursday. I don't know.
Right.
Yeah,
Yeah.
I have a
Wow.
lot of tests here. But look, this is the ones of the last trimester. Oh, this is what I did. Look, this is last trimester. Look,
Let's see.
it's a lot of tests.
Ooh.
Like I think it's like 30 tests per
Holy cow! It's
trimester.
just test after test.
Yeah, and we have like less than 1 month to do it.
Wow, really? Less than 1 month?
Yeah. But I'm getting good grades. Like I get 90 in math, 85 here.
Nice.
Yeah.
Good. Okay. Well, yeah. If you ever need me to help with any of the biology or chemistry or anything, let me know.
Yeah. Our chemistry, it's easier than physics, but it's still difficult.
Yeah. What are you doing in chemistry right now?
Let me see what she's asking in the test. Okay, I think she still doesn't send the test of chemistry. That's good because I would probably just have to send it in March. So that's better.
Oh,
for
really?
me.
Do you get a little
Yeah.
break?
We just have a little break when we are at the last week of sending the tests, you know?
Yeah.
So
When is that?
we don't have classes per 1 week to do the tests. But when the classes get back, it will be different probably, you know?
Oh, they're changing it.
Yeah, that school, it's like one of the best schools of my state here because it's technic and it's a public school. So it's difficult to get there, you know?
Oh, look at you, Samuel.
Yeah. I used it to study in a private school, no, but that's the better schools here. But this one, it's the one of the hardest ones because
Really?
it's free and it's better than the private ones.
Yeah,
know?
if you're a mechanic afterwards, that's pretty great.
Yeah, it's because when I finish school, I get mechanic. I turn on mechanic.
Nice. So is that something you're interested in, or is that just an extra plus that you can use
I don't
whenever
want
you
to
want?
work with mechanic. I just say I'm a mechanic, but I don't want to work with it.
Yeah.
I
That's
want to be
nice,
an
though.
officer.
Oh, yeah?
Yeah, a federal one.
A federal officer.
Yeah, this is look.
Okay. After this, I'll have to go.
Look, that's what I want to be.
What do you have to do after high school to do that?
I need to do like some courses about this because to be an officer here and to be from a federal one, you need to do university. So I'll do law university because doing law university, I can be a sheriff. You know.
Yeah. You're gonna do law.
Law, yeah.
Wow. Nice. All right. Well, it'll be good to know a Brazilian doctor, or a lawyer,
Yeah, to be from the federal policy, you need to do university. You can't be without doing university.
How many years of university do you do? 3 or 4?
4. But you can. Here is not like United States. You have free universities, but it's hard to get in. You know.
Yeah.
It's hard to get in. You need to do this test called ENEM. ENEM, it's what you do after finish school. So when you do this test, you can see which universities you can join, you know?
Okay. Yeah. Americans have a similar sort of thing.
Yeah, but here the universities that you get can be for free. And
That's
there, I
nice.
think it's so
crazy.
expensive.
It's crazy. Yeah. I don't understand how it
Same
makes sense.
as healthy there, it's so expensive, right?
Yeah.
Here we have public
Yeah.
health.
Same with here. We have public
but
health too, so it's
but it's
nice.
not so good like the private hospitals. So me and my family we have a healthy plan, you know.
Do you have like a private and public healthcare?
Yeah, look, Chip. Oh, I'm mixing my language and English, sorry.
That's okay.
But when you if I get cancer right now,
Yeah.
I can go to INCA. That's a public hospital that it's like
Yeah.
I don't let me see it. It's cured to cancer, you know?
Right. Right.
We have
Okay.
those things here.
Nice.
So, but if I just I just break my arm, I can go to a public hospital and that will be fast.
Right.
But if you want like
The
let me
best.
see like the a lux
Luxury.
place,
Yeah.
yeah,
Yeah.
you can go to a private hospital. I have a health plan. I think that's how you call it.
Yeah. Yeah.
I don't know.
Yeah.
Yeah, health plan. I have it. So me and my family we can go to a private hospital.
Nice.
But if you don't have, you can use the public one.
Right.
You know.
Right. Nice.
It's just my school. Look. It's big inside of it because we have a lot of laboratories. I don't know how to say it. A lot of labs.
Oh,
Yeah.
really? What do you
Really,
do? What
really,
does the
yeah.
school do in the labs?
Things about mechanic like you
Ah,
need to
all
use
the machining labs.
yeah, a lot of machines
Right.
and we have a lot of those things, microscopes. And we need
Ah,
to
nice.
use it to see the metal inside. I don't know how to explain it, but that's
Yeah.
it.
Nice. That's great.
I never had a presential class there. I just went one time to a visitation that had like 3 months ago, I think.
You haven't
I
done
just
anything in
wanted to-
biology?
Hmm?
You haven't done anything in biology in the labs?
Yeah, probably. It's because
Oh, you haven't had biology
we
yet.
didn't have class in presential school, just online.
Oh,
But this
right.
year we'll come back to school.
Oh, that's good. Yeah, that'll be good for
Yeah.
using that stuff.
I want to go to school. Like I don't go to school since 2019.
Oh my gosh. So you've
think,
been online
yeah.
fully?
Yeah.
Holy cow.
Yeah. I still see friends because my friends that live near me, but I want to go to school. I miss.
Yeah, it's
Okay.
tough.
Oh, here I have one chemistry test. I just saw it.
Oh, perfect.
This is. Let me see what she asked. No, it's all in Portuguese, but
Yeah, of course.
I think it's easy. I don't know.
Yeah, it's not so bad.
But I have a problem that I can't pay attention on online classes. You know, it's so boring.
Yeah, it's tough.
This is my
Okay,
classes.
just come here. Come here
Okay,
after
okay.
class and I'll help you, okay?
Yeah. I can't pay attention on this, and the professors are so bad
Really?
online. Yeah, I don't like them.
Yeah, I've
My
heard.
English teacher is so
Are they
boring,
like
and
older? They don't know what's going on with the computers? Is that what's the problem?
Yeah, some of them.
Yeah. Yeah,
I
that's I think a
have a
big
teacher
problem.
that she looks like 70 years old or something like that.
Oh my gosh, you must be
And
struggling.
that's hard. That's hard. Yeah. When I used it to study in another school, we had a teacher that was so old and he didn't know how to use computer, and
Oh god, that must
that
have been
was so
scary.
hard. That was hard.
Yeah, that must have been bad. Like, check your email, it's there, I sent it.
Yeah. It's like my grandfather. He doesn't know how to
Yeah,
use
exactly.
those things.
Exactly. Same with my grandmother.
Yeah,
Okay, Samuel, I
that's
have to
sad.
go. Thank you
That's
very
okay,
much
that's okay.
for stopping by, for hanging out. Hopefully you come back soon.
Thank
Bring
you,
your
thank you.
friends. Okay?
Yeah.
And,
Thank you for helping me.
Yeah, no problem. I'll put the PDFs in the Discord, okay? I'll put the notes.
Oh, okay.
Okay?
Can I ask you for help when I get chemistry and something like that?
Yeah, of course. I'll be
Chemistry
here.
and biology.
Of
those
course.
things.
Biology, chemistry, physics, math, whatever you
Yeah.
need, okay?
This is my worst thing, but you don't know probably it's mechanic things.
Let's see.
This is worse than physics and things like that.
This is just
Look.
calipers.
Yeah, look those things. I
Yeah,
look
yeah, yeah.
this and I don't know what to do.
Okay.
This is so sad.
Yeah, I'm not too comfortable with them, but I you know, if they needed me to, I can maybe look it up.
Okay. I send you a message when I need chemistry.
Okay.
Chemistry classes.
Perfect. All right.
Thank you so much.
No problem. See you. Have a good night, okay?
Thank you. Good night. What
Bye.
time is it now in Canada?
It's 9:45, same time as you.
No, here is 11:41.
Oh shit. Okay.
Yeah.
Oh yeah, it's 9:45.
Thank you
I'm
so
in the
much.
Eastern time zone. No problem. Nice to meet you, Samuel. See
Good
you.
night. Good night.
Thanks for
See
being
you.
nice. See ya.
See you.
Bye. All right. That was great. Thanks, Samuel. Appreciate you stopping by. So I'm gonna put our PDFs in the chat. Actually, I'll put them in the Discord. Okay. I'm gonna change this. I'm gonna change this Discord. I'm gonna change the channels around, and that way we can have a PDF channel that's just the PDFs. Okay, thanks everyone for stopping by. Appreciate it. Preach. And we'll